Now we are starting with this new topic, coordinate geometry. And coordinate geometry, generally speaking, it's a topic about Cartesian coordinate system. Cartesian coordinate system means we would be dealing with the XY plane. And for XY plane, definitely we would be having some X coordinates and Y coordinates involved. Since it says geometry, geometry means we would be dealing with different geometrical shapes. Now, when I say different geometrical shapes, it can be the straight lines as well as any bounded shape. Bounded shape means we can be having triangles and we can have in different quadrilaterals. So geometrical shapes may it can be lines, it can be triangles, and it can be quadrilaterals. And for quadrilaterals, we can expect rectangles, squares, trapeziums, parallelogram. So for all these triangles and quadrilaterals, we should be knowing their respective properties. For example, if I may talk about square, so for square, we should be knowing that square has all four sides equal in length. First thing, second thing, all four sides are making an angle of 90 degrees with each other. So we should be knowing the basic properties of all these geometrical shapes. So we would be studying about all these geometrical shapes on the Cartesian coordinate system. Cartesian coordinate system means the XY plane. Either I say Cartesian coordinate system or I say XY plane, they both mean the same thing. So about this topic, there are few formulas to be remembered, and we'll go through all those formulas one by one with their examples. All right, so the very first concept or the formulation to be remembered is the concept of gradient. Gradient, it is defined as change in one variable with respect to another. And for us on this xy plane, we have the two variables as x and y. So change in one variable with respect to change in another. Looking at this figure, we can see the two different changes along the two different directions. We can see the change in the x direction, and we can see the change in the y direction also. Okay, this is a change in the y direction. So change in x direction means it is basically x2 minus x1. X2 minus x1 means there would be some, if we are talking about 2 points, the 2 points here are point A x1 y1, point B x2 y2. So we have two x coordinates and two y coordinates here. So when we say change in x coordinate, that is eventually x2 minus x1. And when I say change in y coordinate, that would be y2 minus y1. Since gradient is about the change between the two variables, so the formula in simple terms, it can be m is equals to change in variable y, which is y2 minus y1, change in variable x, that is x2 minus x1. And in some books, you'd find the same formula also written as rise over run. Why rise over run? Rise over run means vertically it's always a rise. So how much there has been a change in the vertical direction, and run means the change in the horizontal direction. So rise over run. That is the first formula. We can do a few examples about it. For example, you have the 2 points A and B given as, let's suppose, 2 comma 4, and B, the second point, this is 6 comma 12, and you have to find the gradient of AB. So it would be 12 minus 4 upon 6 minus 2. So change in y, which is 12 minus 4, change in x, that is 6 minus 2. So 12 minus 4, that's a 8, 6 minus 2, that's a 4. We get the gradient as 2. And it's not necessary that we would always be having the numbers involved when we talk about gradient. We can also expect variables there. For example, like here, if these are the 2 points and we have to find their gradient, the basic idea remains the same. For us, this would be x1, y1, and this would be x2, y2. Using the gradient formula, it would be 3k minus of minus k. Make sure you don't miss out the minus sign. That is why I'm writing it here, it as minus of minus k upon x to my second, that is k minus 2k. So m would be equals to 3k plus k upon k minus 2k, that's a minus k. So we get this as 4k upon minus k. K and k gets cancelled, giving us 4m as minus 4. Okay. And at the same time, we can also expect the questions where the gradient would be given to us, and there would be one of the points missing. For example, in case of this example, we have been given with the gradient, and we are supposed to find one of the missing coordinates. A. Gradient is given as 2. So since the gradient is given, so we'll definitely start with the gradient formula. And if you want, you can label these points as x1, y1, x2, y2. The gradient in this case, m is equals to y2 minus y1 upon x2 minus x1. Gradient is given as 2, so 2 is equals to 5 minus a upon 7 minus 4. 2 is equals to 5 minus a upon 3. And now the basics of algebra would be applied here, making them cross multiply. So 2 into 3, that's a 6, is equals to 5 minus a. And a would be equals to 5 minus 6, giving a as minus 1. So these are the types of questions we can expect about gradient. After gradient, another important concept related to the Cartesian coordinate system, it is the concept of distance or length. So here again, we are talking about the xy plane, and for this xy plane, we would be dealing with the 2 points only. So for these 2 points, A and B, if we have to find the distance between the 2 points, for distance, we also use the word length. If we have to find the distance or the length between these 2 points, we have the formula as length is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so where x1 and y1 represent the coordinates of the first point, x2, y2 represent the coordinates of the second point. Let's pick up an example here. Let's suppose we have the 2 points given as P, which is, let's suppose, 3, 5, and we have another point Q, which is -1, 8. And the question says, find PQ. Either it says PQ or it says length of PQ. They both mean the same thing. So we'll use the distance formula here, keeping in mind that 3, 5 would be x1, y1 for us, and -1, 8 would be x2, y2 for us. So using distance formula, PQ is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. So x2 minus x1 whole square means that would be 8 minus 5 whole square. Sorry, it's x2 minus x1. It's going to be -1 minus 3 whole square plus 8 minus 5 whole square. -1 minus 3, that's a -4. -4 square is a 16. And 8 minus 5, that's a 3. 3 square is a 9. We get this as 25 PQ. Now, important thing to be remembered. If the question says give the answer in the exact form, then this would be the final answer. Exact form. Exact form means you keep the answer in the third form in this case. Because whenever it says exact form means no rounding off, no decimal value. Exact forms are usually given the answer as the surd form, the fraction form, the answer in terms of pi, the answer in terms of this under root form. But here in case of this particular question, we know that 25, it's a perfect square. So we can find the exact value here. So it would be square root of 25, which is a 5 only. So here in this case, you cannot expect the answer to be in the exact form. Why? Because under root 25, it's a perfect square and you can find the root of it. So PQ, it's 5 units. And then like the case of gradient, here as well, we can expect the cases where the distance would be given to us and one of the coordinates would be missing. Now look at this question. Here it says the distance between the points is 5 units. And we have to find possible values of k. So one of the coordinates is missing here. And one more important thing to be focused on here is they're using a plural term, values. The plural term is an indication that you should end up getting more than one values of k. And most probably you'll end up getting a quadratic equation. Because quadratic equation is the only possibility that would give us multiple answers and which would be giving us the two possible answers. So you have to be focused and you have to keep in mind that plural term means values means there should be definitely two or more answers. Now let's start this question since the distance is given, so you have to start with the distance formula, which is
सर ये मिड टर्म से भी हो सकता है
yes. But since the distance is given, so we'll be using the distance formula. X2 minus x1 whole square plus y2 minus y1 whole square. Distance is 5 is equal to under root of x2 minus x1. That would be 0 minus 3 whole square plus k minus 5 whole square. Simplifying it further, we'll get this as minus 3, 0 minus 3, that's a minus 3. Minus 3 is a square, that's a 9. Plus, now this k minus 5 whole square, it's a whole square on the bracket. And whenever you have a whole square on the bracket, you always expand using the identity. And the identity, it was a minus b whole square, which is a square minus 2ab plus b square. So applying the identity here, it would be k square minus 2 5s are 10k plus 25 is equals to 5. And this can be simplified further. K square minus 10k and 9 plus 25, that's a 34. Now the thing is, we have this square root here, and whenever we have to finish the square root, we always square both the sides. So square both sides. That would give us 5 whole square is equals to k square minus 10k plus 34 whole square. This square would be cancelling the root. 5 square, that's a 25, is equals to k square minus 10k plus 34. Rearranging it, we'll get the equation now as k square minus 10k plus 34 minus 25 equals to 0. K square minus 10k, 34 minus 25, that is a 9 equals to 0. And you can see that it's a quadratic form now. And to solve this quadratic, you can either use the calculator directly or the middle term break method. So if it's a paper without calculator examination. So without calculator examination, that means you should be able to do it with the help of factorization. So breaking the middle term, you will get this as k square minus k minus 9k plus 9 equals to 0. And then k taken common, k minus 1 minus 9 taken common, k minus 1 equals to 0. K minus 9, k minus 1 equals to 0. And both these factors would be equated with 0, giving us two different equations. So k minus 9 equals to 0, giving us k as 9. That's the first possible value. And then k minus 1 equals to 0, giving us k as positive 1, the second possible value. So this is how you get the two possible values. Is this all clear till now? Any questions?
No.
Okay, let's move on. Another important concept under the heading of coordinate geometry is the concept of the midpoint. So we'll again consider this XY plane that will help us in visualizing the things in a better way. Okay, we have to find the midpoint here. So if A and B, these are the endpoints. Endpoints of the segment. And this is also the endpoint of the segment. And what if we have to find a point which is exactly in the middle of these two endpoints? Let's suppose we have a point here. It is exactly in the center, in the middle of the 2 points, 2 endpoints, and we call this point as point C. And we are interested in finding the coordinates of this point C, x comma y. So the formula for finding the midpoint of the two endpoints, this is x comma y is equals to x1 plus x2 upon 2 comma y1 plus y2 upon 2. This is the formula which we would be using to find the midpoint. Example, let's suppose we have the endpoints given as m and n. M having the coordinates as minus 4 comma 0 and n having the coordinates as 8 comma 8 comma 10. And the question says find midpoint of mn. So using the formula x1 is equal to x1 plus x2 upon 2, y1 plus y2 upon 2. We take this point as x1, this point as y1, x2 comma y2. So x1 plus x2 upon 2 means it would be minus 4 plus 8 upon 2 comma 0 plus 10 upon 2. Minus 4 plus 8, that's 8 minus 4, which is 4. 4 upon 2, that's a 2. And 0 plus 10, that's a 10. 10 upon 2, that's a 5. We get this midpoint as 2, 5. Acha, it's not necessary that midpoint formula will only be used to find the midpoint when the endpoints are given. There can also be a possibility when you are given with the midpoint and one of the two endpoints are missing. I repeat again, here in this example, the two endpoints were given and you were asked to find the midpoint. And at the same time, there can be cases where you would be given with the midpoint and you'd be asked to find one of the two endpoints. Let's pick up an example based on this scenario too. Okay, so we have minus 2, 3 and 3, 1. So let's suppose we have been given with a point P minus 3, 1 and Q, we don't know what it is. This is, we don't know. And P and Q are the endpoints. With their midpoint as 5, 7. And the question says find the coordinates of Q. Okay, so roughly if you might want to draw a sketch here. So we have this as somewhat like this. So P is here, having the coordinates minus 3, 1. Q is here, which we need to find. And we have their midpoint given as 5, 7. So midpoint is given here. This was the midpoint. 5, 7 is the midpoint. And we are supposed to find one of the endpoints. Now we don't know the endpoint here, so we are supposing the coordinates of endpoint as A, B. Okay. We have just supposed the coordinates. So let Q be A, B. So we'll use the midpoint formula. Midpoint formula is x, y is equals to x1 plus x2 upon 2, y1 plus y2 upon 2. Midpoint is 5, 7, so it would come here. X1 plus x2. So x1 plus x2 in this case, this for us would be the x1 and y1, and A, B would be the x2 and y2 for us. So x1 plus x2, it would be minus 3 plus a upon 2. Y1 plus y2, it would be 1 plus b upon 2. So we have set up the midpoint formula here. Now, important thing to be remembered here, when we have 2 points equal, so we can always compare their respective coordinates. Comparing the respective coordinates means we'd compare the x coordinate on the left with the x coordinate on the right, and y coordinate on the left with the y coordinate on the right, giving us two different equations formed. So on comparing the x coordinate, we'll get the equation as 5 is equal to minus 3 plus a upon 2. Cross multiplying it, we'll get 10 is equal to minus 3 plus a, and that would give us a as 10 plus 3, a as 13. For b, we'll compare the y coordinate, and that would be 7 is equal to 1 plus b upon 2. Cross multiplying it, we'll get 7 into 2, that's 14 is equal to 1 plus b, and b again we'll get this as 14 minus 1, that's a 13. So that means this end point q which is missing, this q is having the coordinates as 13, 13. Is this all clear?
Yes.
Okay, now I want you to solve a couple of questions. So these are the 3 questions to be solved. Please solve them and let me know the answers. Okay, so these are the answers for 4 and 5. 4, it's 6 whole 1 upon 2, which is also 6.5. 5, it's minus half. And for question 14, this is 12 and minus 12. 4 and 5 are easy. I'm sure you would have got the answers. 14, I'll do it for you. Since the distance given to us, we'll start with the distance formula. That is under root x2 minus x1 whole square plus y2 minus y1 whole square. Distance is 2 under root 122. x2 minus x1 whole square. This
Sir,
would
plus
be
minus 12 हो रहा है.
x1 and y1. This is x2 and y2. So x2 minus x1, that would be 10 minus x whole square. Y2 minus y1, that would be minus 10 minus x whole square. So applying the identity to expand it, we'll get this as 10 square is 100. Middle term 2 into 10 into x, that's 20x minus x square. Sorry, middle term would be having a negative sign. Minus x square would be positive x square.
Sir,
And now
plus 20x क्यों है?
middle term, you have to apply the identity.
Okay.
A minus b whole square, which is a square minus 2ab plus b square.